Hello, everybody. Thanks for joining. This is the August edition of the App Service Community Stand-Up. I'm your host, Byron Tardif. Thank you so much for being here with us again. And today I have Catherine Wang, who's part of the Azure Cache for Redis team. And we're going to be talking all about how Azure Cache can make your application run faster, smoother, cheaper, better. So Catherine, you want to tell us a little bit about yourself? What's your role in the team, etc.?
Sure. So hello everyone. I'm Catherine. I'm Byron's colleague next door working in Azure Cache for Redis. So I'm a product manager. My focus is on the Azure scenario integrations and really making sure our developers can easily, quickly getting started using Redis and then make sure their journey is successful as they scale up their applications and making everything ready for production.
Thank you, Catherine. So one of the things where we work together is we have on App Service, we have this Web plus database template on the Azure portal where you can go and you can create a web app with your database of your choice. And that is a great template if you're starting out because it sets up not only the web app and the database, but also all of the VNet integration. It uses Service Connector to make your database and your app talk to each other over the VNet and with the least amount of management overhead. That if you've never seen Service Connector lets you monitor your connection so that if there's ever like a password change or a secret change, you know that it happened and you can go do something about it to change it. And the work that we did with Catherine's team is we added the option of also including cache in that scenario. You want to tell us a little bit about that, Catherine?
Sure. So firstly, am I sharing my screen?
Okay, here we go.
Okay. Yeah. So like Byron said earlier, the WebApp plus database template has existed for a while, and we recently added Redis cache into the template. So during the create process, there's one more section in the template asking, hey, do you want to add an Azure Cache for Redis? If yes, then we auto-populate the name and will default the SKUs based on your hosting plan choice. So basic means it's good for dev test research purpose, and then standard is generally good for production. If you want to try out this experience, here is a shortcut to link this in Azure Portal. And if you are starting from Azure Portal, like this is the Azure Portal. If you have Azure subscription, you'll be able to see it easily. So go to the Create a Resource experience, and then search for Web App plus Database. It shows up in the search. The first template, so this is where we added cache integration. If we say create, it directs us to this form where we select the subscription resource group. In this case, I want to create a new one, so new web app cache. And I simply put a name, for example, web app db123. Or okay, a runtime stack. Let's just say Java in this case. Yeah, and it will auto-populate some other field such as the SQL engine recommended, the name of the server, and in the cache section, if I say yes, the name of the cache is also auto-populated. So it's really minimal amount of input, and it will just create me an environment with the web app and the database and the cache. So if I say create.
Yeah. One of the things that we discovered when we did this work is that a lot of people didn't know that there were other database providers apart from SQL on Azure. So if you're looking for Postgres, you're writing a Python application, you're looking for MySQL because you're writing PHP or Java or whatever database provider you want, chances are we have it. Also including things like Cosmos DB, which is the NoSQL implementation that has API compatibility layers with MongoDB. I think there's like Gremlin, and there's like 8 or 9 different flavors of databases that have a compatibility layer with Cosmos. So that's one thing to know. Yeah, basically whatever database or whatever backend you're looking for, it's there on Azure.
Cool. And all this database, if you want to reduce the request load, you can add a cache instance with it. So making sure the content, the request responses will be cached to make your web app run even more efficient and performant.
Right.
So like we said earlier, everything provisioned will be very secure. So this is an example of all the resources created based on the template we were looking at. So you can see everything is secured within a virtual network linked by private endpoint. And everything is configured to be default connected, as in the web app will have configuration settings pointing to the database and the cache instance.
Yeah, and if you're new to Azure, if you've never heard of this thing called a resource group, the way that I talk about it is think of it as a folder where you're putting all of the different components of your application. So that's one way to keep apps separated. It doesn't mean that an app that is in one resource group cannot use resources from another resource group, but it's just, giving you a folder, a way to separate things out.
Mm-hmm. Yeah, so at this point, you may wonder, why are we adding Azure Cache for Redis into this template? And maybe even before that, what is Azure Cache for Redis? Here's a quick introduction. So Redis itself is an open source based project. It's essentially storing everything in memory, supports both key value pair or like NoSQL data store. We partnered with the Redis Inc., who manages the enterprise version of this software offering, and we put this app as a service in Azure. It's for first-party partnership, so everything looks very native in Azure, same as any other Azure services. It has smooth Azure integrations like AAD, and this service itself is performant and scalable, cost-effective, and secure.
So the difference here is you could go create a bunch of VMs and install Redis yourself, but then you would have to manage those VMs. You would have to scale, do the right sizing, patching, updating of the Redis bits, etc. Where if you go with the Redis Azure Cache for Redis offering, this is a managed service. So basically what's happening here is Catherine's team is doing all of that work for you, and you're just consuming the service at that point, correct?
Correct. Yeah, so we are taking away all the management overhead and making sure it runs resiliently, reliably. We offer like SLAs up to 5.9, so it's like really a lot of value add comparing with self-host.
Nice. Yeah, nobody wants to wake up on a Tuesday to have to go patch the Redis cache. That's not fun.
No. Yeah, that's why we have manager service. Like our engineers are doing a lot for you.
Mm-hmm.
So now you may wonder, what are the developer scenarios? Like how do I use this Redis cache with my web application? Here are some common scenarios. The first one, distributed cache. because Redis stores everything in memory and it's like a key value pair. So that makes Redis really great fit for an external distributed cache for improving your web app performance. So if you have repeated data queries or really large, complicated data queries that's slow in execution, you can cache the result, and the next time, without going through all the effort, the cache will just return you the output, so making your web application faster. It's also used as a session data store. So for example, in an e-commerce web application, if you are storing the shopping cart items, those are frequently edited, and until people commit, like it may or may not be final. So storing it in Redis cache, using it as a session store would be much more efficient than storing everything like writing into database. Like those repeated write operations could be slow. And then in the like high performance scenarios, if you are building a really large scale like fraud detection system, IoT scenarios, stock market, it's very common pattern to use Redis for data streaming, as in if you have a lot of events, you can just write to Redis and the QPS can go up to like hundreds of thousands per second. So Redis is a really great fit for the large scale performance data streaming scenario. And some people also use Redis as a message broker. Imagine you have a web app in front that's taking in some data, and then it needs to send to a backend. So you want to decouple these two components by using a message broker in between. So the message broker, such as Redis, will be able to take the message, do some processing as needed, and then the backend can then in turn use this data.
When we're talking about web applications, the most common scenario that we see people using is the data store. And that's because we want people to externalize the session state of their application so that you don't end up with stateful instances. To take advantage of the cloud, you want to be able to horizontally scale. And that's usually the first blocker is the session resides with the specific VM where the request is being served. So if you're able to externalize that using Redis, then you can go and scale to a large number of instances instead of just having to go to a bigger instance every time that you need more scale. So that's I would say the most common pattern where we see people using Redis as a way to store that state that is outside of the VM where the requests are being served.
Yeah, totally agree. Especially for session data, like it's used a lot in the initialization phase of a web application. So storing it in Redis also makes loading it fast. Plus, in the case of like scale in or fail over, you don't want your session data to be lost together with the reduced number of server instances.
Yeah, you bring up a good point, because also if you're scaling down, you're by definition turning off a machine that might have session state in it. So it's applicable both on the scale out and the scaling situations. Or if the particular machine blue screens or whatever, you don't want to lose all of that data.
Yeah, exactly. So as Byron and myself talking a lot through the scenarios, you may wonder, like, can we see a real example? So I'm going to show you an like demo eShop web application. As you can see, this is a eShop web app where we're selling some products online. For each product, you can say view the details, and then if you like it, add to cart. Going to the shopping cart section, you can see like one item's added. We can add a few more items by going to the view and then like add to cart.
Mm-hmm.
And then you can see like on top here, just because I hacked through this, but then the idea is if you viewed an item but decided to come later, then this session information will be saved, telling you, hey, you just viewed this item, and then there's a shortcut to add this item to the shopping cart.
So this is an experience that's configured for you, right? It's not,
yes,
everybody wouldn't see this. It's just because of your history of navigation that you get something like that, which is starting your session state.
Yeah, exactly. So it has a record of all the items I viewed, like until like I go to the shopping cart and decided to check out or not. This is an example of the session state data we were talking about. Awesome. Personalized. And then as I go to the shopping cart, if everything looks good, I can check out. So right now, this app is hosted using a web app instance and database only without cache. What are the potential problems? So like we mentioned earlier, we don't want to put session data in memory with the web server, because if we scale up, scale in, or like if a server failed, this data will be lost. And the sticky session also affect the web app performance. So even if there's no scaling or failover event going on, if one client always have to be routed to one particular server instance, then it will affect the load distribution depending on how long each user stays using the app.
Yeah, and we see that where people that have this pattern, let's say they have 3 instances and they scale up to 6, but because all of their customers were hitting those 3 instances, you end up with 3 instances that are overloaded and 3 instances that are underloaded. So it's not until you get a new session that they start getting assigned to the new workers.
Yeah, so you don't want your servers to be sitting there and then wasting the CPU cycles. Mm-hmm. And in addition to the session state, we were storing all the product information, all the shopping cart information, and the user's identity in the SQL Server directly, which means every time if I reload the web app, it will query the database again to get all the product information. And every time I add an item, it will write directly into database. So in order to make my web app more resilient, more performant, here is the topology afterwards. By adding an Azure Cache for Redis instance, we can move all the session information into the Redis cache, externalize the session store, so people don't have to configure the sticky session, and all your users will be hitting like different server instances. We can make sure the load distribution is even, and the scaling in, scaling out, failover will not cause any data loss. In addition, we can save the product queried information and the shopping cart all in Redis cache. The write to Redis cache is a lot faster than some of the database based on the in-memory nature of it.
So do I need to go and rewrite my application to take advantage of this, like write a bunch of new queries, or how do we enable this?
Yeah, good question. So actually, making an application use cache is pretty convenient. I'm using ASP.NET Core in this example, and I'll talk a little bit about other languages later. But for example, the .NET framework, it supports middlewares like the Redis cache, also the session middleware. It will pick up the Redis cache from what was configured. So all the session information as well as the product, the shopping cart information can be connected to the cache, and we can write it directly into the cache. Leveraging the service interface, I can just add the calls to cache into each service interface. So we don't have to change the whole architecture to use cache. It's just something that works alongside with our existing database queries, and it integrates well with the existing session middleware. And a
Awesome.
similar experience for Java. So for example, if you are using the latest client and if you use Java Spring Boot, there's a tag annotation even to help you simplify all the caching code down to the configuration level. And I believe Node.js also has session middlewares that can work with Redis cache, in addition to the standalone client libraries.
Right. So that's the benefit of the open source world, right? Where it doesn't matter what language you're using. There's probably a couple different libraries and a couple different ways to use this. And because the service that is being hosted on Azure is standard Redis, the patterns that are there for your programming language and your scenario, you don't need to change anything. You need to do things differently. You just use it the same that you would any other cache.
Correct. And now, as we changed our application slightly to use cache, what are the performance impact? So we ran some load tests on both the old instance with database only and the new instance with database and cache. We see really like a dramatic performance improvement. So we reduced the response time 90th percentile to like a little bit more than like 1 second, comparing with the 9.56 second with database only. So you can see in this graph, the pink line represents the instance with WebApp and the database only. The blue line represents the matrix for the app when using cache. So we have reduced the response time by a lot and increased the application throughput. And like we mentioned earlier, so the template starts really quick and simple with some lower tier skills. But as you scale up or scale out your application, you can just make changes to the skills in the resource. In my case, when I did the load test, I scaled up the cache to premium instance from standard. And for even like more load, you can scale up the app service instance. So it depends on like where you think your application's performance bottleneck is. If it's on the client connections, the CPU server utilization, probably you want to scale up your web app. And if the bottleneck is on the data queries, then adding a cache would help.
Awesome. So in this scenario, by adding a cache, we're doing a couple of things. We're reducing the load on the backend SQL database. So you end up, not needing as big of an instance for that, right? You can probably scale down your database. And then the other thing that you can do is you can use the same cache to store your session state, which means that you get better horizontal scaling on the web tier. And with those two things combined, you end up with better throughput. So you're able to handle more requests in a second, and better performance because you're taking less time for every query that you're executing and before you start sending bits back to the client. Did that sum it up?
Correct. Yeah, exactly. So it's performance improvement and as well as the resiliency by making the session store external.
Awesome.
Yeah, and again, here's the quick link to get into the template experience. We encourage everyone to try it, like a spin up instance. One thing I forgot to mention earlier was in the create experience, there is an option to download a template for automation. So because our environment provisioning right now is all based on Azure Portal, but what if you use Jenkins or you use like GitHub and you want to repeatedly provision the environment, maybe for testing purpose, maybe every time you deploy new code. So you can download a template for automation. This will download the ARM template for you, and it gives you the flexibility to customize all the parameters. Like if you have any conventions your company uses, like here is the opportunity for customizing it.
Yeah, so if you're not familiar with ARM templates, ARM is the underlying API for every Azure resource. It's Azure Resource Manager. That's what ARM stands for. And the ARM template is a way for you to express in config, like what resources you want to create, how you want to configure it, and have it all execute in one go. The really cool thing of ARM templates, like Catherine said, is that you can check them into your repo, and you can have separate parameter files. So if you look on the left, there's a set of parameters. Those are the specific config that is going with that particular template. So you could have different parameter file for a production scenario versus a dev test scenario, and one of them could be really large and the other one could be really small. And when you have this thing checked in, it makes it so that everybody can create the same environment and can test on the same environment, and you don't have that config drift where somebody's testing with a config that they did 7 days ago, and your service or your application has moved since then. So this is a really good call out. Thank you, Catherine.
Yeah, so our template is both good for go to the portal, quick create, trying it out, and repeated use in production.
Awesome. Is there anything else, or we should wrap it up?
I have two things really quick to mention. The first one is caching strategy. Like we mentioned earlier, we need to keep the cache and the backend data store consistent. So there are existing patterns, like the algorithms you can follow. Doesn't matter which programming language you use. In our example, we were doing the cache invalidating, which means the application read the cache, and in the case of a cache miss, it will go to the data store, and if the data store's changed, we remove the cached value from the data store, and then from the cache, and then refresh it from the data store. There are other like higher performance write through and write behind scenarios, which means the application write directly into the cache, and the cache keeps consistent with the backend data store using something like Azure Function, for example. And another thing I wanted to, sorry, did I interrupt?
No, go ahead.
Yeah, another thing I want to quickly introduce is the web applications with OpenAI and Redis. So OpenAI has been like top of mind for a lot of our customers lately. I want to introduce some use cases and the patterns for using Redis Cache with OpenAI. So one common scenario in machine learning area is about analyzing the unstructured data. So for example, the audios, texts, and videos, like if I receive a lot of comments in my e-commerce web app, can I quickly summarize the comments so I know do people love it or hate it, or if there's any anomaly like I should pay attention to. So in order to build this type of applications, we need to transform this unstructured data into something we call the vector embeddings. It's like a number representation of all the unstructured data making it really easy to search and analyze. So here's another reference application. The GitHub URL link is here. Basically, the architecture is like we feed data, like the raw data, into a Cosmos DB. And then an Azure function will be triggered, which calls the Azure OpenAI service to translate this unstructured text document into vector embeddings. And the vectors will be stored in Redis cache, which is this component here. And in Redis cache, not only the vectors are saved, but it can also create index such as the flat or like hierarchical small world, to make sure the vectors can be quickly and easily searched. And then everything will be presented on the front end by the web application. So yeah, it's something new and cool we did. Please go check it out.
Yeah, this is really top of mind. I think the AI world is changing so fast that having a working sample and a working architecture that guides you through some of these best practices and the concepts is super helpful. So I'm gonna go play with this right after this. I think I'm really excited about the things that we can do here. Okay.
Yeah, we encourage you to try it out. Yeah, here are the links in case you want to take a screenshot or picture.
Perfect. And we'll throw these links also on Twitter. If you didn't know, we have the AC App Service account, and that's usually where I throw all of the show notes, etc. So we'll gather all of this from Catherine, and we'll share it with you guys as well. But yeah, otherwise take a screenshot.
Okay, that's all I have.
Well, thank you very much for coming and talking to us about Azure Cache for Redis, Catherine. We love having you here, and great collaboration on the Web Plus database as well. And looking forward to whatever we can do for the next one. I think the only thing I have left is we have the next live stream is going to be on September 7th. I still don't know what the subject is going to be, but we're going to try and bring in something exciting. Also in September, there's going to be a Python Community Day that is sponsored by the Azure developer community. So look forward to some exciting announcements around that time. And yeah, I think that's all. Thank you very much, Catherine. Thank you very much, everybody at home, and we'll see you next time.
Okay, thank you. See you.